So I hope you have a good evening. Now, one of the most recent questions that have become common, very many mock papers and very many resource papers have started setting this question. And I thought it necessary to discuss it with you because I understand you have looked at functions and all of them. You may not look at any other functions again, maybe in the revision. So you can be given a composite function. So like finding f of x or g of x given fg of x or gf of x. But remember, when you are to find f of x or g of x, when you are given the composite function fg of x or gf of x, you must be given one of either this, so that you're finding this, or you are given this, so that you are finding that. So we are going to create an example. We learn better with an example, and then we see what we are supposed to do. So we can say, given that fg of x equals 6x plus 6 plus 6, and f of x equals 2x minus 4. Someone says find g of x. Find g of x. So we have been given fg of x, and someone has given us f of x, so they want us to find g of x. So the first thing we do there is to identify if we are given the composite function, and according to what we are given a composite function fg of x, which is 6x plus 6, and we are also given f of x as 2x minus 4. So we are given f of x, fg of x as 6x plus 6. Then we are given f of x as 2x minus 4. So we want g of x. Now, when you look at this fg of x and this f of x, ask yourself, which type of equations are they? We know we have 3 types of equations. We have linear equations, we have quadratic equations, then we have polynomials. Okay, at this level we may not look at polynomials. They may not give you polynomials, but at least O level you can look at linear equations, then quadratic equations. Now linear equations are just equations which do not have like y squared or x squared. They are just linear, like equation of a line, like 2x plus 4, and maybe 3x plus. So they are just linear expressions. Then quadratic, those ones will be having x squared plus y squared plus p squared plus, that kind of thing. So after looking at this one here, which is the composite function fg of x and then f of x, they are linear. Also, f of x is linear. It means that our g of x is also going to be linear. Therefore, we'll expect that for you to find the expression of g of x, it must be a linear expression. It must be a linear expression because it cannot be a quadratic expression. You see that? So after knowing that, now in your mind you will know that, oh, my g of x is therefore a quadratic equation, or is therefore supposed to be a linear equation. So now I think let us work out. We have that if we say therefore, now we have now known that g of x is supposed to be linear. Okay, so how does a linear equation look like? So g of x, you can say let g of x be equal to ax plus b. Ax plus b plus b. Now a question is going to be, why is it ax plus b? I want you to look at, for example, fg of x. It is 6x plus y. You can see that it is in this form here. It is in the form a, where a is x, where a is 6, then b is also 6. That is for the composite. Even when you look at f of x, it is 2x minus 4, which is in this form. Because a is 2, then x is there, and b will be negative 4. So likewise, it means that the g of x should also be in this form. You see that? Now we have, f of g of x means that you have f, and then you are substituting the function g of x in f. You see that? So you have fg of x equals f. Now into f you are substituting g. That's what it means. Okay? Now our fg of x is 6x plus 6 equals, but this is given by, you are going to have a function of f, and then in f where there is x, you will substitute there g of x. So now this is going to be 2 equals 2. Okay? In 2. Now in the function f of x, which is somewhere here, f of x is 2x minus 4. But we know that when we are getting fg of x, where there is x here, we substitute there g of x, which is this. So where there is x, we are therefore going to substitute our g of x, which is ax plus b. Therefore, 6x plus 6 is going to be equal to 2. Where there is x, now we put there ax plus b, and then minus, sorry for that, it is minus 4. So minus 4. Now therefore we shall have 6x plus 6 equals, now we can expand. Now when we expand, we have therefore 2ax plus 2b minus 4, because the minus 4 is there. So now we have 6x plus 6 equals this one here. Now here you have to be very, very wise, and you can see on this one here, there are terms which are having x and there are terms which are not having x. So these terms here are not having x, whereas these terms here are having x. So we shall equate terms together, whereby those that have x are equated to the ones that have x here. So this one is having x, that means it's going to be equated to this one which has x. So we say that implies that 2ax equals 6x. Now the x will cancel, therefore we have 2a equals 6. Divide by 2, divide by 2, a will be equal to 3. So after getting a is equal to 3, remember we said we are equating terms that are similar. This one is not having x, so that means we shall equate it to this one which is not having x also. So we shall therefore have that 2b minus 4 equals, it is equal to what? It is equal to 6. Because these ones here did not have any coefficient of x, so they are constants and they are equal to each other. So that means that 2b will be equal to, if this one comes this side, will be 10 divided by 2, divide by 2. Therefore, b will be equal to 5. And from g of x equals ax plus b, it means that our g of x will be equal to 2, which is ax plus 5 as the answer.